Okay, so Unit 4, Interpreting Vertex Form. Again, we have 3 different forms we're going to talk about today, and all the little things that you can shortcut with it in order to get to your answer quicker. So for y is equal to 3 times x minus 4 quantity squared minus 2, what are the vertex axis of symmetry, the maximum and the minimum, and then finally the domain and the range? Okay, so right off the bat, we need to know we are working with the quadratic equation. So x squared on a fundamental basis looks like this. Okay, so that's, we will call it f of x is equal to x squared. So there's your parabola. This is the fundamental piece that you have. Okay, and what we're going to do is, there are transformations that have been made to this. Here's one, here's another, and here's the last one. Because originally, I had x squared. So those are the transformations that occurred. Okay? And they're the same way as far as in that order that we're going to do it, BCAD. Okay? This is a lot like absolute value for sure. So what's the first transformation that you guys see?
Horizontal shift right.
Yep. So we're going to say horizontal shift 4 to the right. And then vertical, yep. Vertical stretch by what? Yep, by a factor of 3. So even though this is a new unit, there's still some correlation for sure for the test that you're going to have next class. And anyone, what's the last one?
Down to
Yep, vertical shift 2 units down. Okay, so if I did that to this, okay, to this graph, it'll look something like this. Let me go ahead and see if I can do it like this so you can see it. So we'll say there, red. How close am I? Pretty close. Alright, so that's the default. That's where you start. Okay? So it's going to be shifted 4 to the right, 1, 2, 3, 4, and then stretched vertically by a factor of 3, and then shift 2 units down. Can someone tell me what is this point right here? It's the vertex. And what are the coordinates? 4 and -2. Okay? Remember, it's the opposite of what you see in the parentheses, and it's exactly what you see as far as outside of the y. Okay? So 1, 2, 3, 4 to the right, 2 down. Oh, -2. Question so far? Okay, so the vertex is 4, -2. What's the axis of symmetry? X equals 4. Nice. So x is equal to 4 is the axis of symmetry. What's the maximum? No maximum. So no maximum. We'll put max, none. Careful. This is still in the test for absolute value. What's the min? What would we write? Y equals -2. So y is equal to -2 is the min, and it occurs at what? X equals 4. But the answer is the minimum is y equals -2. Okay? What's the domain of the red graph? All real numbers, yeah. So we'll put domain. You can put the r with a double line, or you could put -infinity to infinity, which is what notation? What's -infinity to infinity? Interval notation. And then the last one, and I'm just giving you extra practice for test type of questions, is if it gave you in set notation, it would be the set of all x's such that x is an element of all the reals. And now let's go to the range. So the range, is it all real numbers?
No.
No. So in interval notation, how would you write that? What's the range? Yeah, go ahead, Joel. Brackets?
To then infinity.
Perfect. And if I did that, Catherine, in interval notation, no, not interval notation, algebraic notation, what would I write? Not for a range. Think of range. Range is y. This is x. Okay? And I want to show everything from -2 to infinity. Santiago, what do I write?
Y is greater than or equal to -2.
Okay, yep. So y's that are greater than or equal to -2, for sure. And then, yes, if there's a question that asks what's the set notation, you would say the set of all y is such that y is greater than or equal to a -2. Good? Any questions before I keep going? So this is very similar to what we're doing with absolute value functions, with transformations for sure. Alright, let's move on. So, what are the vertex axis of symmetry, and so on and so forth for this equation here? It's a little bit different. Okay, so let's graph it real quick. But first we're going to list out the transformations that we see. Jordan, what's the first transformation that you see? Yeah, horizontal shift. 1 unit to the left. Corbin, what's the second one that you see?
Reflection across the x-axis.
Yep. Reflects across x-axis. Oh, and what's the third one that you see? Yes, nice. Vertical stretch. Your speed is awesome. Vertical stretch by a factor of 2. And the fourth one. Michael, what's the fourth one? Yep, vertical shift 4 units up. So now, let's go ahead and draw this real quick. We're going to come over here. This is where we start. Real quick, where we start, can someone tell me what is the rise and the run to get from this to this point? What is the rise over run? It's 1 and 1. It's up 1 over 1. Okay? So going back to the other one back here, the original was up 1 over 1. Now I know I didn't draw it to scale, but that's what it's doing. What is the red one? Up 3 over 1 because of that stretch. Nice. I just wanted to make sure that we were good on that. Okay? Alright, let's go back over here. Whoops. And yeah, we're right here. So what we're going to do is we're going to go ahead and transform these. And it's going to, of course, look different. Let's see. And we're going to go through them just like we did the other one, as far as transformations at a time. Let me just line this up before we start, as close as we can. Alright, so from here we're going to shift 1 to the left. We're going to reflect, this is going to be weird. We're going to reflect across the x-axis, which is going to come way over here. And then we're going to stretch by a factor of 2. So now our slope is like 2, right? Down 2 over 1, down 2 over 1. And then we're going to shift 4 units up. Alright, so this vertex, from what we just did, Aaron, what's the vertex? Say it one more time. Negative 1, 4. Yes. Nice. Negative 1, and then 1, 2, 3, 4. Skylar, what is the axis of symmetry? How do?
X equals negative 1.
Perfect. X equals negative 1 because I got to make sure I put X because it's a vertical line. Okay. Daxton, do I have a min or a max?
Max.
A max for sure. And what would you write down as far as that value? Not negative 1/4. That's where it occurs. But I want you to tell me what's the max.
Y equals 4.
Y equals 4. Perfect. Y is equal to 4. Y is equal to 4 is the maximum that it will occur. Nate, what's the domain? All real numbers. And we'll go now. Brittany, what's the range?
The range is y is less than or equal to 4.
Nice. And that same thing, Brittany, but in interval notation.
Interval notation would be bracket for no lying. Parentheses negative infinity comma 4 bracket.
Perfect. Nicely done. Any questions? Yes, Gianna.
So why don't we do anything with the exponent?
That's a really good question. Because my original parent function, the default, came from this function right here. It all starts from this. So what you see is these parentheses, everything that I've highlighted in orange is the same as the original one. The only changes are here, which show that it moved left 1, here, which showed it reflected, here, which showed it stretched, and here, which showed that it shifted. But the default parent function is the same as if you were have written it like this.
So we're not going to touch the exponent?
Yeah, the exponent has nothing to do with transformations. Because if you remember, transformations are multiplication, division, addition, and subtraction, and then negative reflections. There's nothing with exponents whatsoever. Okay? Just like when we did absolute values, we didn't even touch the absolute value. Yes?
On the test, if there's no max or min, do you just want us to not write it? Like, not write none?
Yeah, just write none, if there's none.
Okay.
Alright, so what steps transform? So this one's different. And you can look at this very similar to an absolute value function. It's really, really good practice for the test as well, okay? So Sarah, we are starting off here, and we're going to go all the way here. And what steps are we going to do? Actually, I thought it was something different. It's just pretty much the same as what we did the last two examples, right? All right, so let's kind of, without writing them individually out and graphing them, let's see if we can go to the vertex, the axis of symmetry, the max or min, the domain, and the range. Okay, from what I see right there, what's the vertex there?
It would be -2, -5.
Perfect. Santiago, what's the axis of symmetry?
X equals -2.
Okay. Anna, does it have a max or a min? Minimum. She's right. Anna, how do you know that it has a minimum without even graphing it? There's a characteristic about what we were given, but I want to see if you can see it. What about that shows that it would have a min? Joel?
Like there's no negatives never reflected across.
There's no negatives. So it never reflected across the x-axis. So it's always looking up. Okay? Okay, and Joel, what would be the minimum?
The minimum would be y equals -5.
Nice. Y is equal to -5. And again, he knew that because there was no reflection, and you could really go off of the equation right there. Y is equal to negative 5. Let's see. Grant, what's the domain?
All real numbers.
All real numbers. Nice. And Grant, what is the range in interval notation?
Interval bracket -5, comma, infinity, parentheses.
And the same in algebraic.
Y is greater than -5, or equal to.
Perfect. Okay, that's good. You guys, I know you're going to do very well on this task for sure. Just make sure, again, like I said before, make sure that we do look at those videos because there's some questions that you're going to need to. Alright, so the picture shows the jump of a dolphin. Suppose the path of this jump changes so that the axis of symmetry becomes x is equal to 2 and the height stays the same. If the path of the jump also passes through the point 5, 5, what is the quadratic function that would model the path of this jump? There's a lot going on. Any questions on, or any suggestions on how I could start? Yes, Morgan.
Using the axis of symmetry as your first point for the vertex.
Okay, so the vertex, you're saying, since the axis of symmetry is x equals 2, where does that play into this?
The x would be 2.
The x would be 2. Okay. Any other suggestions out there?
Plot the point 5, 5. Just use as reference.
Okay, so we can use this 0.55. This is on the graph. And 5, 5, it's not drawn to scale, but that's going to be on the graph. Okay? So yes, it's not drawn to scale. I don't know why it's not drawn to scale correctly, but this is 5, 5. You see what I'm saying? It should actually be something like this per se. Okay? What else could we do? Yes? We could find the mirroring points for sure. Let me see. Also passes through 5, 5. I might have to change this because I don't want to confuse you, and some of you are looking confused right now. That picture does not match what we see. It does not. Correct. Do you agree with me? Yeah.
It says the path of change, like you're changing.
Becomes XO.
That's the original.
Thank you, Jordan. So this is the original, and we're changing it to. So this original, the axis of symmetry was what? 3. So x is equal to 3. And we're changing it to x is equal to 2. Okay? And if the path of the jump also passes through. So the new place, I see what you're doing. Thank you, Jordan. The new one is going to go through here. So if the axis of symmetry is at 2, and it goes through 5, 5, here's 5, 5. The axis of symmetry now is at 2. We know that the graph is going to look like from here, something like this. You agree? And it's also, like Catherine said, it's going to mirror somehow over here. Something like that. Okay? So let's go to the vertex form. Y is equal to A, bx minus c, plus d. Okay? The other form that we could use on this is the factored form. As far as the x-intercepts and looking at a coefficient, and the standard form as well. So y is equal to ax squared plus bx plus c. And then the last one is y is equal to ax minus the factored form that you see here and here. So from here, which of these three, vertex, standard, or factor, do you think we're probably going to end up using from the pieces that we're given? It would be the vertex form. Okay? It will be the vertex form. And the way we're going to do this is, first of all, if the axis of symmetry is at 2, our x is going to look something like that. You with me? So now I have an A, and I also have a D to contend with. Is there a D value that you can see from the graph? What's the D? Why is it 7? Why didn't that change? Because the height does not change. It stays at 7. Okay? What other observations can you see? Does it look like there is a stretch or compression of some kind? It looks like a horizontal compression, right? Or it won't be a vertical stretch because then that 7 would move. So it was like a horizontal compression by what? Because my original points were here and like over here, you could say. Maybe we should get the equation of the original, and that might be easier to do first, and then we can go to the transformation, because I think we're trying to do both at the same time right now. Yeah. We can, but I first want to go to, let's do the original one first, and then we'll get to that. That's where we're into, that's where how this problem ends up, is mathematically we're going to solve for those values. Do you see what she's saying? Do you see what she's saying as far as that goes? So here's the thing. You know what? I like your suggestion this early. We'll do it right now. Okay? Do we know A? We really don't. Do you trust that 2 works here? This minus 2. Yeah. The 7 is trustworthy as well, right? So what we can do is we're going to use this, like Catherine was suggesting, right here for x, right here for y, so that we can solve for what? A. So way back when you guys were given something that looked like this, and I said, hey guys, I want you to solve for, and this was like an algebra 1, your teacher asked, solve for the y-intercept. You always had to be given some kind of point so that you could plug them in to the equation so that you could solve for b. You with me? So if you plugged in 1 for x and you plugged in 2 for y, what would b end up becoming? 0. So you would take this equation and it would just be this, because you used a point to get that. That's exactly what we're doing here, but we're using it to find like compressions and stretches and stuff. So let's mathematically put 5 right here and put this y5 right here. You with me? And here we go. We're going to put 5 is equal to a 5 minus 2 squared plus 7. What's our goal right now? So find a, yeah. Find a. Riley, what do I do first? 5 minus 2 is 3. So it'd be like 3 squared is what? 9. Subtract 7. Divided by 9. So this final equation could look something like y is equal to a negative 2/9 x minus 2 squared plus 7. You with with me? So this graph that we have, the new one right here, does it look like it was shifted 2 to the right from the origin? Yeah, it was shifted 2 to the right. Does it look like it was shifted 7 up? Yeah. And it also looks like it was reflected across what? The x-axis. And last but not least, what happened to the graph? It was vertically what? Compressed by a factor of 2/9. You with me? Alright, any questions before we continue? Because that's a big conceptual kind of looking at it, but we use that graph, that point, to solve it mathematically like Catherine suggested. Alright, here we go. I believe we only have 2 more and then notes are done for today. What are the vertex, the axis of symmetry, the min and max value for what you see here? This is different. Any suggestions? And this is a little bit discouraging because so far all we've talked about is vertex form. If I ask you to graph this, Brianna, do you have any ideas on how you could graph this? You could factor it out for sure. How would you factor it? Divided by 2. Here we go. Let's take out a 2 from everything. What 3 letters did we learn that we just did? GCF, right? Greatest common factor. Out of all 3 terms, Brianna just suggested us to divide the greatest common factor. Do you all agree? Okay. Now, if I were to factor this, we're going to learn this unit for sure. Some of you already know how to do this from Algebra 1 because you kind of did it on your own. How could I factor that? I'm just listening. What else, Riley? 2 negative 2? Okay. So again, you shouldn't know per se because we're learning how to do that in this unit. But what I'm going to tell you right now is this is not factorable. It's not factorable. Not with real numbers. Okay, do y'all, I don't know how far they go with you on Algebra 1, but did y'all ever learn the quadratic formula? Okay, so x equals negative b plus or minus the square root of b squared minus 4ac all over what? 2a. Nice. Wow, y'all went all the way there. The most important thing, guys, the most important piece from this is right here. I'm telling you, I teach this over and over to juniors, seniors, sophomores, anyone that I can show. When you're dealing with quadratics, especially on PSAT, especially on SAT and ACT, they test the discriminant test a lot. So, and I might as well show you right now. I want to show you as early as I can. The discriminant test is we're basically going to discriminate on all of this equation. That the only important information that I'm discriminating is the blue part. Because you can get so much information just from what I highlighted in blue. Okay, here we go. If this, it's called the discriminant test. Let me go ahead and write that down. The discriminant test says this. I'm going to test just that piece, and if it follows certain criteria, then I can get a lot of answers from it very quickly. Here we go. First of all, let's look at our original equation. Our original equation is where we need to get this from. Okay, so this is from standard form. You cannot do it in factored form, and you cannot use the discriminant test in vertex form. But you can do it from standard form. What's the a value that you see? 2. What's the b value? 8. What's the c value? Negative 2. So b squared minus 4ac over here is like saying 8 squared minus 4 times 2 times a negative 2. What's 8 squared? 64. Here we go. What's negative 4 times 2 times a negative 2? 16, a positive 16, right? So 64 and a positive 16, the only thing that we care is that it's going to be a positive number. You with me? Okay. Let's come over here. B squared minus 4ac. First of all, if it's a positive number, which this one is, it will have two roots somewhere. It will have two zeros of the function. It will have two x-intercepts for sure. If this b squared minus 4ac turned out to be a negative, it would never cross the x-axis. It'll still bend, but it won't cross the x-axis. You with me? It'll look like this, or it'll be down here looking like this. But for this particular one, I know that it's going to be, if it worked out to be a negative, since this is looking up, it would look like this. Okay? And last but not least, if it equaled 0, it's called a double root. So here we go. This right here has two real solutions, otherwise x-intercepts. This has two non-real, aka, what's the other word for non-real? I don't know if they taught it. Imaginary. Did they ever teach you imaginary? A little bit?
No.
No? Alright, so anyway, I'll teach you now. Two non-real, otherwise imaginary solutions. And the last one is, it's one double root. A double root bounces off the x-axis. You with me? This one has two answers also, but they're not real. This one has two answers, but we only write it down one time. You with me? Look at this graph right here, the very, very bottom graph. And if I were to ask you to tell me, that looks like a parabola that was shifted to the right. What could we write that equation to look like? Like 1, right? So like what? X plus or x minus? X minus 1 squared. What Brianna was talking about earlier as far as that doesn't change. The reason why this is called a double root is because this is counted twice. This right here is the same. What's 2 squared? 2 times 2. What's 35 squared? 35 times 35. So what's x minus 1 squared? It's twice. You with me? And what we're going to do a lot this year, or this unit, is we're going to set these quadratics equal to 0, and we're going to solve, when does that happen? Well, here it happens at x is equal to 1. Here it has x is equal to 1. Technically, there's two answers, but it's only one of the same. They're not two different numbers. So you would say this, but it's a double root, because it accounts for it twice. Yeah?
So when you get the same number twice, are you automatically going to assume that it's a double root?
Yeah, for sure. You with me? My point is, you have two answers here. These are different. You have two answers here, but one's an exact copy, so we call it a double root. And you still have two answers here. And the biggest reason why you will always have two answers, whether they're real, non-real, or double root, is because it's quadratic. X squared. If it was x cubed, how many answers would I have? 3. If it was x to the 8th, how many answers would I have? 8. They could all be the same. Like x is equal to 0, 0, 0, 0, 0, 0, 8 times, but nonetheless it's still 8. Questions before I keep going? Because we're not done yet. We still have to do some stuff on this one. There's just a lot that you also needed to learn and get exposed to, even with this problem that I wanted to show you immediately. All right, so this is what you should have gotten from this. Or this is what you should know from this. When you are given something in standard form, the shortcut, I'm not even kidding, I'm saying probably 5% of people remember this shortcut. But about 90% of the time, it's tested on SAT and ACT. Okay, here we go. When you are given in standard form, the way to get the vertex very quickly is to do negative b over 2a. Okay, and again, this comes from the standard quadratic of ax squared plus bx plus c, where we know a is 2, we know b is 8, and we know c is negative 2. Okay, here we go. So if I looked at negative b over 2, this is kind of close to the discriminant test a little bit. It's dealing with these a's and b's. This would be a negative 8 over a 2 times a. What does that simplify to? Negative 2. So negative 2 is the x-coordinate of the vertex. How do you think we find the y from this? Plug it in. We're going to plug this in to the original equation where you see x. And people get a little bit intimidated by that, but it's not. It's just this. Plug it in as an input. So if I plug in negative 2 into the original one, it's like saying this is f of x. What's f of 2? You with me? So let's plug this in. So it'd be 2 parentheses squared. Remember what we did long ago when things were much easier? Did you already go to the final answer? Oh, thank you. Negative 2, which is very important. What will that be? Positive 4. So we have 8. Whoops. What will this become? Negative 16. A lot of mistakes with negatives tend to happen here. And then minus 2. What's my final answer? Negative 10. So negative 2, negative 10 is the vertex. Vertex is done. And again, I'm just teaching you this. Once you learn it and you do it with practice, you will fly through this. Okay? So if we know the vertex, do we know the axis of symmetry? Yeah, what is it? Say it again? X equals negative 2. So this is the vertex. There's the axis of symmetry. Max or min, what do you think? Min, perfect. And the way you can tell from the standard form is what is the sign of that coefficient of x squared. If it's negative, it's going to look down. Okay, so if it was a negative 2, it would look like this. But because it's a positive 2, it will look up. Positive people, you could say smile, and negative people, if it was a negative, tend to frown. Okay, that's a good way to remember it. So max and min, we said it was a max, or sorry, a min. What do we write for the minimum? Y equals negative 10. Okay. What's the range? Or sorry, not range. What's the domain? All real numbers. And what's the range? Y is greater than or equal to negative 10. Otherwise, negative 10 to infinity. Like that. I don't want to go too fast, but at the same time, I want to make sure everyone is building this familiarity of pieces. Okay, last one. This is the last one for today. What are the vertex axis of symmetry, maximum and minimum values in range for what I see here? So be ready. I'm going to call on you and just talk me through it as far as the pieces go, okay? Alright, let's start with trivia. Vertex, what do I do? Negative b over 2a, yep. And yep, because it's a negative b, which will become a positive 4. Yep, and trivia, what do you get as a final answer for that? Which will reduce to what? Or negative 2/3, right? So guys, negative 2/3 is the same as 2 over negative 3. Okay? Probably that one's the one that's most commonly used. Cool. Alright, so negative 2 over 3. And now I need the y value. Okay? Tyson, what do I do to get the y value? Plug it back into the original equation. So let's build that. Negative 3 parentheses squared minus 4 parentheses plus 6. I'm plugging in a negative 2/3. Tyson, tell me what to do next. What does that end up becoming? Oh, without a calculator, without a calculator. Positive or negative? Positive. True or false? Everything that is squared will always be positive. True. True or false? Everything that is raised to the power of 4 will always be positive. True. So where am I going with this? Anything raised to what? An even number will always be positive. Does that work with odds? No, it does not. Okay? So it will be a positive. So guys, if you need to right now, for the steps that you're at and the level that you're at right now, write it 2 times. There's so much to learn from that. And anyone, you tell me, what would this be squared? 4/9. So I have negative 3 times 4/9. This is times. This is not the same as a mixed number. It's not the same. And we've talked about this. Negative 3 is the same as negative 3 over what? 1. And we've talked about this. We are always trying to reduce before multiplying. Reduce as early as possible. So don't say 12 over 9. You're doing too much. And when we get to the harder ones, it's going to take you forever. But if you reduce 3/9 to what? 1/3. Now all you have to do is multiply a negative 1 with a 4 and a 1 with a 3. And it's already reduced. You with me? So what do I get? Negative 4/3. Do we agree? Okay, so now let's move over here. A negative times a negative is a what? Positive. So it'll be a positive, and I'm thinking 4 over 1 times 2 over 3. Can any of the top reduce with anything on the bottom right now? No. And when you can't reduce, then you multiply straight across. Alright, so 4 times 2/3, and anyone becomes what? 8/3. And then we're going to add 6. With me? So now that we're going to add these all together, we do need common denominators, which I do not have right now. I have 3, 3, and 1. I'm going to multiply by a form of 1, which is 3 over 3. And guys, when you multiply by a form of 1, don't try to cancel it right out again, because you're undoing what you were trying to do. The reason why you did that is so that you could get the common denominator. 3, 3, and 3. Bringing them all together gives you this. What do I write for that last space? 18. So negative 4 plus 8. 4 plus 18 is 22. Is 22 divisible by 3? No. So this would be 22 over 3. Yes, you're going to have fractions. Okay? I'm contemplating whether or not I should show you synthetic division because you can learn it. It's not that difficult. Well, not right now. Not yet. Not yet. But look at you. All right, so no. I'm saying because you don't necessarily learn synthetic division until pre-cal, but there's no reason why you can't learn it now. All right, axis of symmetry. Anyone, what is it? Yep, x equals negative 2/3. That synthetic division actually helps you a lot. And yes, we will learn it. Maximum or minimum values. You tell me, is this going to have a max or a min? It's going to have a max. Because it's facing what? Downward. Okay? So what is the max? Y equals 22 over 3. Learning this quickly. That's awesome. What is the... I don't know why they didn't list it, but what's the domain? All real numbers. Can someone tell me why? Or not yet. Not the range. Why is the domain of quadratics, otherwise parabolas, why is the domain all real numbers? Let's say you didn't know it looked like that. Let's say you didn't know it looked like that. Think about this. Why would the domain be all real numbers?
Because the equation x is squared, so like no matter what the value, even if it's a negative, it'll always yield the same y value instead of y. So like when it has that shape, push back out down the shape.
Did you hear what he's saying? Because, listen, I'll repeat it. Because look, everything that is squared will always yield a number. That's part of it, but that's not the biggest part. The biggest part that it's all real numbers is on this equation, I never divide by what? 0. There's nothing ever over 0. So that's why the domain for this one would be all real numbers. Now, just because it doesn't divide by 0 doesn't mean that they're all going to be all real numbers. We're going to learn other pieces, but I want to get those in your brains right now. We'll finish it off. Jordan, what is the range? Yes. Nice job, Catherine. Okay, so as far as showing this in interval notation, Jordan, what's interval notation for this range? Parentheses. Perfect. And then bracket. Yes, nicely done. Any questions, guys? Alright, so that is it. What I want you to do now, though, is I want you to, go to Desmos. And this one is that weird one as far as, you can do it from the calendar, okay? So from the calendar, I don't think I did that calendar with you, did I? So remember when we did these, like, the Desmos, whenever you can log in with a class? Do y'all remember what, you are yeah, student Desmos? That's what you're going to do. You're going to join XVAZFX. XVAZFX. Okay, so whenever you do that, this is actually pretty cool. I've never seen this. This is the first year that I've seen this because Desmos is stepping it up. Here's the goal. Your goal is to get all the stars when you launch it. Check this out. So if you launch it, all these will get all the stars. So they're going to become more involved. So when you go to your next one, you're going to change the equation that you see there to get all the stars. Now, for some reason, this isn't showing up, but yours, it has like some kind of parabola here. You see what I'm talking about? There should be a parabola on y'all's. Yeah, y'all have them on y'all's. And then just alter the parabolas going through. Let me see if I can. So, not that one, but this one should do it there. It's not doing it on mine for some reason, but on yours it will have the parabola. And you're just going to do transformations on those parabolas, trying to get as many as you can. They do get difficult as you go through, but it's good transformation practice. And then that's it. We'll do this for the rest of the class.